the environment that contains all things, then time contains the changes of all things within it. A flower from blooming to withering requires a certain amount of time. A human life from birth to death also requires a certain amount of time. A house from being built to collapsing also requires a certain amount of time. Time is perhaps a rather complex topic and not easy to visualize. Time is always around us, it always exists and is the basis for us to record life on Earth. It is a constant that keeps the world, the solar system, and even the universe always operating. Earth has experienced many brilliant civilizations that then decline. Stars are born in the universe and disappear. To track all events occurring in the universe and on our Earth, people compare them in the past with the present while time continues to move forward. But is it really a constant? Is time really as simple as moving from one second to the next? According to estimates, the universe was born about 13.8 billion years ago, and since then, time has continued to flow until today. Time witnesses how galaxies are created and the expansion of spaces. Earth may be 4.5 billion years old, and modern humans have lived here for about 300,000 years, which is only 0.002% of the universe's age. This comparison makes us feel that humans are very small and insignificant. In fact, we have spent very little time on Earth. In terms of astronomy, the time humans have lived on this planet is negligible. The 17th century physicist Isaac Newton considered time like an arrow shot from a bow, moving in a straight line and never deviating from its path. For Newton, 1 second on Earth has the same length of time as 1 second on Mars, Jupiter, or in deep space. He believed that no motion is absolute. That means nothing in the universe has a constant speed, not even light. By applying this theory, he could assume that if the speed of light could change, then time must be constant. Time must pass from 1 second to the next, with no difference in the length of any 2 seconds. This is something people easily think is true. Each day has about 24 hours. There is no day with 26 hours or one with 23 hours. However, in 1905, Albert Einstein asserted that the speed of light does not change. To be precise, it is a constant, moving at about 299,792 kilometers per second. He assumed that time is like a rippling river, flowing depending on the effects of gravity and space-time. Time could speed up or slow down when approaching cosmic bodies with different masses and velocities, so 1 second on Earth is not equal to 1 second elsewhere in the universe. This raises an issue. If the speed of light is truly a constant, then there must be some variable that changes over large distances in the universe. In the expanding universe, 2 planets and galaxies moving on a galactic scale, like humans, need something to allow these small fluctuations to occur. And this variable must be time. Ultimately, Einstein's theory was not only believed to be true but also proven to be completely accurate. In October 1971, 2 physicists named J.C. Haffel and Richard Keating began to prove its validity. To do this, they took 4 cesium atomic clocks on airplanes flying around the world eastward and then westward. S theory at the U.S. Naval Observatory in Washington, when compared with ground-based atomic clocks, Haffel and Keating. This was a truly astonishing result. The clocks actually recorded differences by moving eastward and westward around the world, compared to the U.S. Naval Observatory. This proved that Einstein was correct, specifically with his theory of time dilation, and that time truly fluctuates throughout the universe. So what happens during time dilation? What does the special theory of relativity mean in terms of time? It is a physical theory that has been experimentally confirmed and widely accepted, discussing the relationship between space and time. The special theory of relativity is based on 2 axioms. First, the laws of physics are invariant or homogeneous in all inertial reference frames, making reference frames moving without acceleration. Second, the speed of light in a vacuum is the same for all observers, regardless of the motion of the light source. Newton and Einstein agreed on one thing: time always moves forward. To date, There is no evidence of anything in the universe that can evade time and move back and forth at will. Everything ultimately moves forward in time, possibly at a steady speed or slightly distorted if approaching the speed of light. However, can we answer why time passes? Not entirely, although there are some hypotheses about why it is so. One of these involves the laws of thermodynamics, specifically the second law. This states that everything in the universe tends to move from low to high or from order to disorder. Starting simply from a random Big Bang in the universe, then orderly galaxies appear. And subsequently, humans and organisms on Earth emerge up to today. Analytical chemist Hill Price said this is called the arrow of time, or sometimes referred to as the arrow of time, coined by the British astronomer Eddington in 1928. Eddington argued that time is asymmetric. If we follow the arrow, we find increasingly more random elements in the state of the world, then that arrow is pointing toward the future. If the random elements decrease, the arrow would point toward the past. For example, if you observe a nearly homogeneous star, but then see it explode as a supernova and become a dispersed nebula, you will notice that time has shifted from a state of calm to chaos. Another hypothesis suggests that time passes due to the expansion of the universe. As the universe expands, it pulls time along because space and time are interconnected. But this means that if the universe reaches its theoretical expansion limit and begins to contract, then time will reverse, creating a minor paradox for scientists and astronomers. Would time truly reverse, with everything returning to the past, and then progressing to the beginning of the Big Bang in the universe before ending? That might be unlikely, but other hypotheses have been proposed. Scientific advancements in time research have far surpassed imagination over the past century. From ancient sundials to modern atomic clocks, we can even track the passage of time more accurately than ever before. Time remains a complex topic, but thanks to science, we are getting closer to uncovering the secrets of this unchanging cosmic constant. Thank you for watching this fascinating video.